To solve this exponential equation, first notice that both 1/2 and 4 can be written as powers of 2. 1/2 can be expressed as 2 to the power of -1, and 4 can be expressed as 2 squared. Using the power rule of exponents, we multiply the exponents. Distributing -1, we get -x minus 7 as the exponent, and 2 times 3x gives us 6x. Since the bases are the same, we can set the exponents equal to each other. Add x to both sides. Then divide both sides by 7. We get x equals -1. Unlike our previous problem, where both sides had the same base, this equation has different bases, which means we cannot directly equate the exponents. Instead, we'll use logarithms to solve for x. Apply the logarithm to both sides. Using the power rule, we can bring the exponents down as coefficients. Expand the right-hand side by distributing log 7. Now we collect all x terms on one side by subtracting x times log 7 to both sides. Then factor out x. Isolate x by dividing both sides by the expression 3 times log 2 minus log 7. This is the exact solution. If needed, we can approximate the value using a calculator. X is approximately 14.57. Here's a logarithmic equation. We can start by applying the power rule of logarithms, which allows us to bring down the exponent as a coefficient. Dividing both sides by 3 gives us log base 3 of 8x minus 7 equals 4. Next, we rewrite the logarithmic equation in exponential form, where 3 is the base and 4 is the exponent, and the result is 8x minus 7. Isolate x by adding 7, then dividing by 8. 3 to the 4th power equals 81 plus 7 is 88. Divided by 8, x equals 11. Here's a natural log equation. Since the natural log expressions on both sides are equal, the arguments must be the same. Set the arguments equal to each other. Move all the terms to one side by subtracting 6x from both sides. Now we have a quadratic equation. Let's see if it's factorable. We look for two numbers that multiply to -16 and add to -6. -8 and 2 work. Using the zero product property, we get x equals 8 or -2. Since we are working with logarithms, we must check for extraneous solutions. For the natural log to be defined, its argument must be positive. When we substitute 8 for x in the original equation, we get natural log of 48, which is valid. How about -2? Substituting -2 for x results in a negative argument, which is undefined for the natural log. Therefore, 8 is the only valid solution.